Hello guys, today we are going to discuss gas laws, and if you have not subscribed in my channel, please subscribe and then give a like to my videos for you to be updated of any videos that I upload. Also, you can tap the link button, you see it there, so that you can get the notification. Today we are going to look at gas laws, and gas laws we are going to look at three basic laws. That is, we have something called Boyle's law, we have Charles' law, and we have combined gas law, and then we have the Graham's law. But for today we are going to discuss Boyle's law and Charles' law, and briefly the introduction of gas laws. And gas laws, we shall find that it will deal with the properties of matter in gaseous states. And these properties, we are going to consider some interrelationship such as pressure, volume, and temperature, and look at how they relate. And look at how they relate to each other for them to be used in our day-to-day lives, and how we can able to calculate the pressure if may be needed, the volume needed, the temperature, or any change of this interrelationship in our calculations. Now, we know that in gas we have forces of attraction that are very weak, and therefore this makes the particles of the gases to be in continuous random motion. Therefore, by them being in a continuous random motion, you will see that what happens is that their kinetic energy increases. And therefore, if the kinetic energy is the energy that is required, for example, from one particle to another, they collide. As they collide, they increase the kinetic energy. Also, the pressure also will increase, and therefore you find that they will be bouncing. They will be bouncing from one place to another, and that with that they will occupy any available space. Therefore, let us look at our interrelationship between pressure and volume and temperature. Now, as we look these gas laws, for example, our first one is Boyle's law, and Boyle's law, we are going to ask ourselves how it states, not testing, how it states, and if you shall find that it uses pressure and volume at constant temperature. Therefore, we'll find that when pressure increases, the volume will decrease, and the volume increases, the pressure decreases. Therefore, it will find that it states that when a volume of a fixed mass of a gas when the volume of fixed mass of a gas increases, is directly proportional. The volume is inversely proportional to its pressure and constant temperature. For Charles' law, it deals with the volume and temperature and constant pressure. This one we say the volume of a fixed mass of a gas is directly proportional to its temperature and a constant pressure. Therefore, we find that for Boyle's law, let us protrude like this. You will find that for Boyle's law, you will find that pressure is inversely proportional to volume. It's inversely proportional to volume, like that. Therefore, it means when pressure 1 increases, volume 1 it will definitely decrease. So you have pressure 1, volume 1, will be given by pressure 2 volume 2. What we are saying is just the changing in this interrelationship. Maybe you are given pressure 1 volume 1, pressure 2, and then you are asked about volume 2. You just make volume 2 the subject of the formula, and with that, maybe for this case, we divide by pressure 2 on both sides for us to get volume 2 is equals to, will be given by volume 2 will be given by, remember this one has cancelled out, pressure 1 volume 1 over pressure 2, like that. Anything that you are asked, as long as you have this formula, you just mix the one you are being asked, the subject of the formula. For Charles' law, we know that volume 1 over temperature 1 is equals to volume 2 over temperature 2. Therefore, you find anything that you are asked. In a question, it will give you 3 of this interrelationship, and then they will ask you only 1. So the key thing here is to know to make something the subject of the formula. If you are being asked about volume 2, temperature 1, you just make it the subject of the formula. Then we have, we will do more question on this later in our videos, so that you get it right. For combined gas law, it combines, as the word suggests, all the interrelationship: pressure, volume, and temperature. And you find that you'll be given the initials, like pressure 1 volume 1 over temperature 1 is equals to pressure 2 volume 2 over temperature 2. And therefore, again, make the subject of the formula one of these things. Now, if pressure 2, for example, you have been asked pressure 2 is the question, then it means you divide both sides by V2 over T2. So we multiply here by V2 over T2, so that it will give you V2 P1 V1 all over T2 T1 is equals to pressure 2. Yeah, like this one. You just multiply it here. Hope you are seeing. You can be able to follow like that. Another thing we shall look at this is the standard conditions. Standard condition we shall look at STP and at RTP. At STP, it means at standard temperature and pressure. At standard temperature and pressure, if you find that temperature at STP is always 0 degrees centigrade, and when you convert this one into Kelvin, it is always 273 Kelvin. At RTP, temperature always, at room temperature, it always 25 degrees centigrade. But when you convert into Kelvin, you only add 273 and give this one gives 298 Kelvins. So whenever you have been asked at STP and RTP, the temperatures at STP is 273 Kelvin and at RTP is 298. The pressure on both is very common because it is always both at STP and RTP 760 milligram heat of mercury. That's all. Next we shall meet on calculations and also diffusion and Graham's law. But remember to subscribe, you like, and hit the bell or the link button